Okay, class, picking up where we left off at, we had 500 times the parenthesis 1.0125, and now we have to do the exponent 4 times 100, which is 400. And this will give us A is equal to $71,942.04. Again, $71,942.04. Now we go down here to C, using the same formula, but now our interest rate is 6%. So we will put A is equal to 500 times the parenthesis 1 plus 0.06 divided by 4, and that will be taken to 4 times 100. So now we have A is equal to 500, and when you add up the parentheses, it'll give you 1.015, and that will be to the 400th power. And your final answer would be A is equal to, we will have $192,924.29. Again, $192,924.29 is your final answer. Now we come to our next example. It says in 1626, Peter Minuit bought Manhattan Island for $24 worth of beads, cloth, etc. If the value of the land increased at 5% until 2010, what would be the value of the land in 2010 if the interest was compounded annually? So we have A is equal to, we know it'll be P times 1 plus R over N to the NT power. So now we will have A is equal to, the initial investment was $24, and we will have 1 plus, it was 5%, and N is the number of months. It says the interest was compounded annually, so then that would be N would be 1, and then we will have 1 times T would be the time. So from 1626 to 2010, we can go off to the side and subtract 2010 minus 1626. Let's see, this would be 10, that would be 4, that would be 0, and that would be 10. This would be 9, this would be 3, so this would be 0. So it's 384. So it's 1 times 384. So our A is equal to 24 times 0.05 divided by 1 is 0.5. So this will end up being 1.05 to the 384th power. So now we put this in our calculator, and we will have A is equal to, we will have 3,287,774,968. That will be the final answer for A. Now we scroll down here to B. It says the interest was compounded monthly. So we will have A is equal to P times 1 plus R over N to the NT. A equals 24 times 1 plus, our rate is 0.05, which is 5%, over N, which is 12 months. So we would take N times T, 12 times, we had is 384 years. So it'd be 12 times 384. So we had A is equal to 24. And then in our parentheses, we would just leave this the same. So we would need to put this in a calculator. And 12 times 384 is 4,608. And our final answer here would be 5,027,378,968. $918.04. Now we go to C. The interest was compounded continuously. We have A equals P times E to the RT. So A is equal to P is 24. E, the rate, is 0.05. And the time, of course, is 384 years. Now, we will add 24 e to the power of 19.2 because 0.05 times 384 is 19.2. And our final answer would be $5,231,970,592.30. And that will be our final answer. Now, we go to the next section of this lesson. It says planning for the future with compound interest. Calculating present value. The present value of money to be received in the future is calculated based on the amount of interest that could be earned if P dollars were invested now. If an account earns compound interest, the amount of money that should be invested today to obtain a future value of A dollars can be determined by solving the compound interest formula for P. The formula for compound interest can be modified to calculate the present value of money. Now, we have these formulas here. This is the formulas that we would end up using. Now, this is basically a repeat of what we had up previously. This is the present value in order to get the value that we're seeking. So this is what you have to presently invest in order to get the desired result at the end. So now it says example. How much money should be deposited in an account today that earns 6% compounded monthly so that it would accumulate to $20,000 in 5 years? So we have P is equal to A all over 1 plus R over N to the NT. So we will have P is equal to A is 20,000 divided by, we will have 1 plus, our rate of interest is 6%, which is 0.06, all over 12, because it's 12 months in a year. And then our N is 12 and our T is 5. So next, we will have P is equal to 20,000 divided by, now we change this to a decimal, this will end up giving us 1.005. And that will be taken to the 60th power. Now after we put all those values in our calculator, it will give us that we would need to invest $14,827.44 to end up with $20,000 in 5 years. Now, it says, what is the present value of $5,000 to be received in 7 years if the money could earn 6% compounded quarterly? So we have P is equal to, again, A over 1 plus R over N to the NT. So we have P is equal to, future value is 5,000. We have 1 plus, the rate is 6% to 0.06 all over. This was compounded quarterly, so it would be divided by 4. And we will have 4 times 7. Because N is 4 and 7 is the time, how many years it would be. So we will have P is equal to 5,000 divided by, in this parenthesis, you would end up with 1.015. Your exponent would be 28. So now for the final answer, actually it's supposed to be P, not A. So we will have the present value would have to be $3,295.50. So now we come to our next example. Now this time, well, it's still compounded monthly. So we will have P is equal to A over 1 plus R over N to the NT power. So we have P is equal to our A, it's 100,000. So we have 1 plus our R is 0.05. And then our N is 12 because it's compounded monthly. So then we will have 12 times 20 here for our NT. So we have P is equal to 100,000 divided by, we will just put this 1 plus 0.05 over 12 in our calculator, and it's to the 240 power. Okay, so now that we know this, now we want to put this in our calculator, and our final answer would be $36,864.45. That's how much you would have to start off with in order to end up with $100,000 after 20 years. Now we come to our next problem. Now this one is compounded continuously. So we have P is equal to A over E to the RT. So we have P is equal to our A is $5,000. E, our rate of interest is 6%. So it's 0.06. And our time is 7. So now we will have P is equal to 5,000 divided by E to the 0.42. Now what we need to do with this problem here, we need to put it in our calculator, and we will have P is equal to $3,285.23, and that will be our present value of the money. Now we need to go to effective annual yield. The effective annual yield or effective rate is a simple interest rate that produces the same amount of money in an account at the end of 1 year as when the account is subjected to compound interest at a started rate. Said another way, the effective rate of interest is the equivalent annual simple rate of interest that will yield the same amount as compounding after 1 year. Now, understanding effective annual yield. You deposit $4,000 in an account that pays 8% interest compounded monthly. Find the future value after 1 year. It says use the compound interest formula to find the account's future value after 1 year. So we will have A is equal to P times 1 plus R over N to the NT. So we have A is equal to, our present value is $4,000 times 1 plus, the rate is 8%, which is 0.08, divided by the N is compounded monthly, so it's divided by 12. And then our N is 12, and our time, see, it looks as though it's 1 year because it says after 1 year. Okay, now we have A is equal to 4,000. And in parentheses, we will still just put this in our calculator. And we know this will be taken to the 12th power. So our final answer, and it's an approximation, is $4,332. And that is the final answer. Now, we scroll to our next example. It says use the future value formula for simple interest to determine the effective annual yield. Remember, the effective annual yield is the simple interest rate, so use the future value formula for simple interest to determine rate R. So we have A is equal to P times 1 plus RT to the T. And now we substitute.